The sun blinks out without a sound. A perfect black disk hangs where it used to burn. The sky turns the deepest color you have ever seen. Birds stop mid-song and drop into silence. Streetlights flicker on across cities at noon. Something massive is still pulling Earth in a circle. But no light, no warmth, no golden afternoon. What exactly is hanging there in the sun's place? And how long can our world survive beside it? Stay with me, because the answers are stranger than you think. Imagine swapping the sun for a black hole of equal mass. Gravity stays identical, so Earth keeps its orbit. We do not get flung into space. We do not spiral inward. The math is surprisingly calm. The black hole would be tiny, only about 6 kilometers wide, a whole star compressed into a city block. From Earth, it would be invisible to the naked eye, just a missing patch where the sun belonged. But the consequences begin instantly. Without sunlight, the sky goes dark across the entire daytime hemisphere. Stars appear at noon, the Milky Way arches overhead, Earth becomes a planet of permanent night. The first thing you notice is the silence of color. Everything fades to gray, then to shadow. Plants stop photosynthesizing within minutes. The base of every food chain quietly switches off. The air still feels warm for now. Oceans, soil, and concrete hold heat like a giant battery. But that warmth is borrowed, and the universe is about to collect. Within hours, temperatures begin sliding downward. The drop is gentle at first, almost unnoticed. By the first night, frost forms in places that never freeze. Deserts cool faster than anyone expects. By day 3, average global temperatures fall below freezing. Rain turns to snow on tropical beaches. The oceans begin growing a thin skin of ice. Waves slow under a glass-like crust. Animals that depend on warmth retreat, hibernate, or die quietly. Ecosystems unravel from the bottom up. Humans, however, are clever. We have stored energy, sealed homes, and a knack for survival. Greenhouses light up under artificial suns. Geothermal towns become precious real estate. Cities near volcanoes, hot springs, and nuclear plants suddenly hold the keys to civilization. By week 1, the surface oceans freeze meters deep, but far below, liquid water remains. Earth, in this scenario, becomes something astronomers already know well, a frozen ocean world. Think of Europa, Enceladus, or Titan. Dark, icy shells hiding seas underneath. Life there is not impossible. Around deep-sea vents, ecosystems already thrive without any sunlight. Tube worms, microbes, and strange shrimp feed on chemistry, not photons. They would barely notice the change. So while the surface goes silent, the deep ocean keeps humming. Earth would not become entirely dead. Now look up at the thing in the sky, or rather the thing you cannot see. The black hole itself emits no light, but its surroundings can be spectacular. If even a wisp of gas falls toward it, that gas heats up violently. It forms a thin, glowing accretion disk before crossing the point of no return. In a perfect swap, there is no gas waiting nearby, so our black hole stays mostly dark. A silent, invisible anchor holding 8 planets in their familiar orbits. Mercury still races, Venus still glides, Jupiter still rules the outer court. The solar system looks the same on paper, but feels like a haunted ballroom. Light from distant stars bends slightly as it passes the black hole. Astronomers call this gravitational lensing. Through a telescope, the sky behind the sun's old spot would appear gently warped. Rings of distorted starlight could form, glowing like a faint cosmic halo. It would be the most beautiful, eerie sight humanity has ever recorded. But beauty does not bring back the harvest. Crops fail across every continent within weeks. Food reserves shrink, supply chains freeze, sometimes literally. Society must reorganize around heat and light. Underground farms powered by nuclear and geothermal energy become the new breadbaskets. Vertical greenhouses replace open fields. Humanity does not vanish. It contracts, adapts, and learns to live like deep-sea creatures. Would you want to be alive to witness a sky like that? Tell me in the comments below. A noon full of stars, a frozen ocean glittering under galaxies. Terrifying, yes, but unforgettable. Now stay with me because the physics gets even stranger from here. Without sunlight driving the atmosphere, weather changes completely. Wind patterns weaken as temperature differences shrink. Hurricanes fade, jet streams stall, the sky becomes calmer than it has been in billions of years. But cold air sinks and snow keeps falling. Glaciers begin marching from the poles toward the equator. Within a year, much of the continents were a thick, pale coat of ice. Sea levels drop as water locks into ice sheets. Old coastlines emerge as frozen plains. Earth, viewed from space, would resemble a pale, cracked marble, a snowball circling a hidden sink. Meanwhile, the black hole itself just sits there, patient, compact, almost boring up close. It does not suck things in like a vacuum cleaner. Gravity at Earth's distance is unchanged. Only if you got dangerously close would the difference become deadly. Tidal forces would stretch anything nearby. But Earth stays 150 million kilometers away, safely orbiting, safely ingored by the monstrous appetite. What about radiation? A real black hole can shine brutally when it feeds. Quasars, the brightest objects in the universe, are simply black holes with enormous meals. Our scenario assumes a starving one. No companion star, no gas cloud, no buffet. So Earth is not blasted by X-rays. We freeze in peace, not in fire. Could humanity ever escape this slow, icy fate? Possibly, with technology far beyond today. Giant mirrors in space could focus distant starlight. Fusion reactors could mimic the lost sun. Some scientists imagine harvesting energy from the black hole itself. Spinning ones store enormous rotational power. A civilization advanced enough might tap that spin, draining the monster to warm the planet. It sounds like fantasy, but the physics surprisingly allows it. Real equations describe it. For now, though, we would simply be cold passengers on a darkened world. Zoom out, and the rest of the galaxy notices nothing. One sun-mass black hole is unremarkable. The Milky Way already hosts millions of them, quiet, dark, drifting between stars. Some planets out there may orbit such objects right now, frozen, ancient, unseen. Astronomers actively hunt them using gravitational lensing and stellar wobbles. The search is ongoing. So our thought experiment is not pure fiction. It is a window into other worlds. Worlds where life, if it exists, hides under ice. Worlds lit only by starlight and chemistry. Earth would join that quiet club, a former garden, now a dark aquarium. And yet the deeper lesson is not about black holes. It is about the sun. We rarely thank a star for simply existing, for shining steadily for billions of years, for pouring warmth onto oceans, leaves, and faces without ever asking anything back. Replace it with silence, and you feel the gift suddenly, painfully clearly. Our planet is not just lucky in its distance or its atmosphere, it is lucky in its star. A calm, middle-aged sun, perfectly tuned for life to take its time evolving. A black hole could hold our orbit, but it could never hold our biosphere. Light is not just energy, it is the language every living thing learned to speak. If this thought experiment made you look up differently, hit subscribe and ring the bell. There are many more big what-ifs waiting in the dark. And tell me below which star, planet, or cosmic swap you want explored next. Because somewhere in the universe, a world like this one really exists. And somewhere, a sun like ours is shining. For now, only on us.